All right, I'm going to do an example energy explanation problem with free fall. Here's the scenario. Pause the video and read through the scenario so you know what's going on. Okay, we're going to start with our LOL. We're going to start with the initial. And you could talk about K or UG, either one here. The first thing we're going to say is they're going to have the exact same kinetic energy starting off. So same K. And that's because, oops, and you have to have two things on here because they have the same mass and same speed. So remember, K is equal to one half mv squared. So same mass and same speed, means same kinetic energy. The next thing they're going to have is they're going to have the same UG. Oh no, they're not going to have same UG. Let's look at this. The one on the left over here, we'll call that student A, has more UG because same mass and higher up. So the one on the left, and then we'll fill in our LOL. This is how we know what to fill in. So more UG for A because they have the same mass, but A has more height. And so in our mind, we're thinking of this equation here, UG equals mgh. We know that they have the same mass and one has more height, so that one must have more UG. So then let's draw that on our LOL. I'm going to say they're each going to have 2 blocks of K because they have the same mass and the same speed. And then we'll say the one on the left is higher up, so it's going to have 2 blocks of UG, and the one on the right is lower, so it only has 1 block of UG. Okay? So that's our L initial. The next one is looking at the O, the energy transfer. And on here, there's no energy transfer in or out. There's no work done because we don't have any outside forces. We don't have anyone pushing or pulling or friction. Now, you may say, whoa, hold on. They threw the ball. But remember, our initial is right after the throw. And so that push force on the ball by the hand happened after the throw. So that's not in the time period we're looking at. So we'd say no energy transfer. Or you could also say no work done. Says the same thing a different way because no outside forces. Remember, our equation is the energy transfer, the work done, is the force exerted times the displacement through which that force was exerted for. And if F is 0, then the distance doesn't matter. The work is nothing. All right, now L final. Now this one comes down to figuring it out based on the other parts of the graph. So I have 2, let's do our little basic equation. 2 plus 2 plus 0. This has to equal 4 over here. And over here I have 2 plus 1 plus 0. This one here has to equal 3. So how is that energy going to be stored? Well, the final point is right before the ground. So that's physics code word for 0 height, so 0 UG, and all K. Now, how much K do I need? It's got to be 4 because energy must be conserved. I can't just disappear some energy. On ball B, right before the ground, again, 0 height, so 0 UG. And how much K? I must have 3 kinetic energy. Now, our question was, which student's ball hits the ground with the fastest speed? This, I have not answered it yet. I now know that ball A has more kinetic energy, But that's not the same thing as speed, and that's our concluding statement is going to address that. First, we need to explain how we knew that there was more kinetic energy for the final on A. So we'd say Ka is greater than Kb because, let's see, let's say, well, we can say that it's all K because no height. So we're saying, okay, there's no UG. So no UG. So we're saying, okay, it's all kinetic energy. If it's all kinetic energy and A started with more energy and no work was done. Now there are a bunch of different ways you can say this last thing. How we figured it out, all I'm doing is writing out how I figured it out that this K was 4 and this K was 3. Remember, I said no height, so 0 UG, so I talked about that here. And then I said this equation here has to be true. 4 plus 0 equals 4, 3 plus 0 equals 3. And so this one started with 4, this one started with 3, so I say, oh, A started with more energy and no work was done, right? So if I start with more energy and no work was done, I got to end with more energy. This is conservation of energy. This is what we're applying right here, conservation of energy. All right, claim. Let's say you're not sure. You're like, I don't know. Well, this one has more kinetic energy, so probably. Let's pretend we don't know. Write a concluding statement that supports your claim, and it's asking about the speeds, the velocities. So immediately this is what you're going to do. You're going to jot down the equation that has to do with the thing that the claim is asking about. So it's asking about the speed, and we're wondering about what's happening here. And then we want to look at how do they compare? How do these variables in this equation compare? Well, it said same mass, so they have the exact same mass, and we know that A has more kinetic energy. A has more kinetic energy. So then we look at this and we say, okay, more kinetic energy with the same mass, how is that possible? That must mean that A must be going faster. And that's our concluding statement. It's just about the variables in that equation. So same mass with more kinetic energy means A must have a larger speed. And so faster for ball A, our claim must be that. Okay? All right, so there's a view of the whole problem, all the work that's done. The explanations here are explaining your LOL. So if you're not sure about the LOL, start working through the explanations. The equations support the LOL. So if you're not sure if you said enough things, look at the equation, and you have to address all the variables that might change. So K, same K, because same mass, same speed, same mass, same speed. Or here, we talked about UG, and we talked about mass and height, UG, mass and height. Don't need to talk about little g, the gravitational field strength, because we're all here on Earth, we're not changing that. So be careful for that. And then this last one is how did you figure it out? How did you get this last one here? And it's based on the first two. Your concluding statement, remember, is only about one equation, and you have to talk about all the variables in that equation. And you don't need to reference this entire thing. The concluding statement is very short. So look at what the claim is. It's going to ask about mass or height or velocity or whatever, and then see what equation that variable is in, and then you want to talk about each of the variables in that equation. All right, there you go.